video is on chapter 1, and it will teach you about the difference between a chemical and a physical change. So after you're finished watching this video, you should be able to distinguish between a physical change and a chemical change, and you should be able to identify the 4 ways that we would recognize a chemical change. So to start, we're going to talk about physical changes. And in a physical change, whatever you do to that material, whatever change you make to the material, will not result in any kind of a change in identity. For example, if I take a piece of paper and I rip it in half, or I fold it, or I crumple it, either way, when I'm done, I still have a piece of paper. It might look different, but it's still paper. And therefore, what I did to it was a physical change. Now, other examples of physical changes might be a change in physical state. And when we're talking about changes in physical states, we're talking about the differences between changing from a solid to a liquid, or maybe even to a gas. Now, these processes have names. I apologize here for the marker. It's not working really well this year, but we'll figure it out. So if I'm going to take and change a solid from a liquid, like think of solid ice to liquid water, we call that process melting. But if I take the opposite, liquid water, and I go back to a solid, so any liquid to any solid, the opposite process is called freezing. If I go from a liquid to a gas, that is called evaporation. And if I go back from a gas back to a liquid, that process is called condensation. Now, it is possible to go straight from a solid to a gas, and that process is called sublimation. And it is also possible to go from a gas to a solid, and that process is called deposition. This happens like in the winter time. If you've parked your car out all night and it gets really cold overnight, and you come out to the car in the morning and there is frost on your windshield, that frost has formed as a solid from the water vapor or gas in the air. So those are examples of changes in state. So any one of these, melting or freezing, evaporating or condensing, subliming or depositing, those are all examples of physical changes. In the case if we use water, when water freezes, it is still H2O molecules. They're just now closer together. Other examples of physical changes would be grinding or crushing a material, a gas that's expanding, like a balloon that gets larger. That's all physical changes. There's lots of these. But just remember, the key in a physical change is what you start with and what you end with are the same. Same identity. Now, in a chemical change, what you start with and what you end with will be different. So in a chemical change, the properties of the substances are different because you've changed them chemically. We usually call a chemical change a chemical reaction. And in a chemical reaction, there are 2 important words that we're going to use. The first word is a reactant, and a reactant is a substance that we're going to start with that will undergo the change. So a reactant is there at the beginning. Then once the change happens, there are going to be new products formed, and those products, those things that we make, are called products. So those are some terms for you to know. Now, how will you recognize if a chemical change has happened? Well, here are 4 ways that you can use, pieces of evidence that you can look for to see if a chemical change has taken place. You don't have to see all 4 of them at the same time, but you might see 1, 2, or 3 of them. Some, very rare cases, you might see all 4. So first one, the color would change. If you take a piece of white paper, you light it on fire, it's going to burn, and then you're going to blow it out. And what you have left at the end is not white paper anymore. It's actually kind of black and ash looking. That is an example of a color change. Another example would be like leaves changing color in the fall. Those are all chemical changes. Number 2, if what you do forms a gas, and that's without heating usually. So think about this for a second. If you take an Alka-Seltzer, now if you don't know what an Alka-Seltzer is, ask me tomorrow to show this to you in class. But an Alka-Seltzer, if you put it in water, it will immediately start fizzing and bubbling. And that indicates that a gas is being produced. And those bubbles indicate that a chemical change has happened. But it's because the gas is being generated, not because you're adding heat. Boiling water will bubble, but that is a physical change. Okay, so be very careful with that. Number 3, formation of a precipitate is when a solid forms from 2 solutions. Now this is hard to imagine, and so our next class period will show you what that looks like. We'll do an example of this in class, but for now it's important to note that a precipitate is a solid that forms from 2 or more solutions, and I'll show you this as a demonstration. And then the last one is measurable in some cases a lot more easily than others. The energy change happens. Now, you will either feel it get hot or feel it get cold. But I want you to note that this is an energy change, not a temperature change. That's a big deal. If I heat water, the temperature will change. But that does not mean necessarily that the energy changed in a chemical reaction. What I'm talking about, if you guys can all think to some experiences, if you've used an instant cold pack and you give it a shake or a crack and it immediately starts getting cold, that is an example of an energy change where energy is absorbed, okay, and it's getting cold. And you're getting cold without cooling it. Now, the opposite of that would be like a hot pack, an instant hot pack. You give it a crack or a shake, and it immediately gets hot, and you haven't heated it. That's an example of energy being released. And we use words to describe those. When it's getting hot, we say it is exothermic. Exo means out, so heat is leaving outside of the reaction. When it gets cold, we say that it is endothermic. Endo means in, and heat is going into the reaction, leaving the outside feeling cold. We will show you examples of these in class so that you get a chance to see this for yourselves. But what we want to do is practice this. Now, there are 10 examples here. We're going to do the first 5 together, and then the second set of 5 are your learning check for this. So I want to determine if this is a chemical or a physical change. So let's look at mixing iron and sulfur powder. If all I do is mix them together, you're going to just get a mixture of powders. Both of them will still be iron and sulfur when they're finished. So this would be a physical change. If you're going to cut a piece of paper, cutting the paper will just leave you with 2 pieces of paper, both paper at the end. So again, that is a physical change. Now, if I burn lighter fluid, I'm going to burn the fuel, and will there be what evidence will we see? Well, if you go back to the 4 signs to recognize a chemical change, when you burn something, the color is going to change. So, because you're going to see a color change and energy will be released, that is a chemical change. If I dissolve salt in water, now if I dissolve salt in water, it disappears. I can't see it anymore. But what could I do? What would happen if I heated that water back up? Eventually the water would evaporate, and what would be left behind is the salt. So even though they're in different forms than they were, water was still water, it just evaporated. Salt was still salt, so that is a physical change. And in the last case for our video, if I boil water, water is a liquid at room temperature, and if I add heat to it, eventually it will turn into a gas. That is a state change, and that also is physical. Now, I would like you, for your learning check, to do the last 5 examples and decide to the best of your ability if it's a chemical or a physical change. And if you're having trouble deciding, imagine if you would see one of these 4 pieces of evidence, and that will help you decide if it's chemical or physical. Remember to ask questions in class if you have to, and we will show you some examples of these in our next class period.